Okay, good evening. Welcome to the North Jersey Astronomical Group. We're doing some online stargazing here for you. We have with us Mark Zdarsky, chair of our observing committee,
How we
and
doing?
also Omar Radawan, who's one of our observers and photographers. And so we're going to take you all a tour of the nighttime sky, show you some of the interesting things that are visible in the fall sky here. And so I'm going to share my screen here. We're going to start out, take a look at the southwestern part of the sky. We're set up for tonight around 9 p.m. And as you face the southwestern sky, we've got two planets visible, really quite easily found over in the southern and southwestern sky in the early evening. And you can see we've got Jupiter and Saturn, with Jupiter being the brighter of the two. So this is where these two planets are located right at the moment. They are actually in the constellation of Sagittarius. So this is the constellation Sagittarius, which is the archer, supposed to be a centaur in Greek and Roman mythology. I, as well as quite a few other people, have a lot of trouble seeing a centaur here in the sky. So what we look for is we look for some stars in the shape of a little teapot. And you can see it, there's the pot is right there. You've got three stars that make up the spout. You've got a little handle at the back, and you've got a little triangular shaped top that sits on the top of the pot there. And so that's the teapot of Sagittarius. And so it's a pretty easy pattern to pick out in the summer sky. And now that we're heading into fall, well, that summertime pattern is setting over in the southwest. And falling right behind the teapot, you do have Jupiter and Saturn. And notice how close together they are. They're even closer than they were earlier in the summer if you've been looking at them. And so as time goes on, these two planets are getting closer and closer together. And I think we've mentioned this before in one of our previous programs, that Jupiter and Saturn are heading towards a conjunction. And that just simply means these two planets are going to be very close together in the sky. And this happens once about 20 years. These two big planets get very close together in the sky. And this year is particularly close. But unfortunately, it doesn't happen until December. And by the time that is happening, the conjunction itself, I think, is December 21st. And by that time, those two planets are going to be really low over in the southwest. It's going to be very difficult to view. And so really the best time to view these two planets is not at the conjunction. It's been in the summer, and right now is the best time to look before they get too low in the sky. So we've got Mark's telescope set up on Saturn. We're pointing right at Saturn. And so, Mark, if you could share your screen, we'll give them a view through your telescope. And you can tell them a little bit about tell about what size telescope you're using and that sort of thing.
Okay, maybe I'll do it before I share my screen. Turn my flashlight onto normal light instead of, if you can see behind me. Oh, right there.
There you go. Yeah.
There we go. Yes, that's a 14-inch Skywatcher Dobsonian, complete with, there's a ZWO ASI 294 camera, and that camera, you can see the lines coming down to it, and there's the motor drive for the computer on the telescope, and it goes right into my laptop over here. I'm going to shut this light down. All right, so it's a pretty large Dobsonian, but the major thing is that it's tracking. So there's motors actually driving this telescope. I'm going to go share the screen now so you can see what we're looking at. And here we go. And here we can see Saturn. It's relatively the seeing, which is the atmosphere. So you kind of see this boiling effect. So you're the image won't stay steady all the time, and that varies from night to night. And tonight, the seeing is not terrible, but it does get unsettled every once in a while. But you can definitely see the planet and its rings, and occasionally you can see one of the major divisions within the rings called the Cassini division. So if we pay attention and watch for it to settle down, you'll see the ring, and then you'll see a tiny line within the ring. Kevin, how many moons does Saturn have now? It's over 70, I think.
Oh gosh, yeah, we're up to something like 82 or 83. They haven't all been confirmed yet, but yeah, I guess it was 2 or even 3 summers ago they announced they had found evidence of 20 more satellites orbiting around Saturn, and so it's could be up to 83, which is the most in the solar system.
So
And,
at some point, what's going to differentiate between a captured asteroid and a moon, or a satellite?
yeah, some of those especially the outer satellites of Saturn, really do seem to be captured chunks, and they're actually even rotating backwards or revolving backwards around the planet. And so yeah, are they really moons? We don't really have a set size, a minimum size for a moon. So I think at some point we should probably set one, because after a while you'll end up with hundreds of little tiny specks of rock being called moons. Right. It's kind of a little ridiculous. So
right.
At some point have a cutoff, because, okay, 83 is enough, and or 85
Exactly.
is enough, and just kind of stop there,
Right.
So yeah, lots of moons orbiting around Saturn, and if you look carefully, I don't know if you can see, Mark. I think I see a little bit of a shadow from the planet on the rings there on the left-hand side. So that's kind of neat, because it gives you a nice kind of 3-dimensional look to it.
Right. Kind of 11 o'clock position. Is that what you see?
Right.
Yeah.
Yeah. Just at that position there, you can see. If you point to it with your mouse, can you put it with?
Yeah. Sorry. Yeah. This guy
right
here.
Yeah, right there. That's
right
I think it's a little bit of a shadow of the planet falling on the rings there, which is always kind of neat to see. And believe it or not, the rings of Saturn are not always visible. There are certain parts of Saturn's orbits where the plane of the rings is pointing kind of right at us, and the rings almost kind of seem to disappear, and you don't get the good view. Right now, they're pretty much, I think we've passed maximum, but they're pretty wide open at this point. We're looking down on the rings, and we have a really nice view for the next several years. Now, it does take, 29 and a half years for Saturn to go around the sun. So you do get several years of good viewing of the rings. Then they disappear, then they come back,
Right. So they tips into the other hemisphere, and you see it, the other side of the ring, so to speak.
Right,
yeah.
Right. Yeah. And
so
nice view of Saturn. Yeah.
Do you want me to move on to try to look at Jupiter?
Yeah, sure. Actually, while you're moving, let me share my screen again, just to show you where we're going to be moving the telescope while he does that. And so we have the telescope pointed at Saturn at this point. We're going to move over, and we're going to take a closer look at Jupiter. And so we're going to zoom in to Jupiter here. And if I show you a close-up view, I'll give you a little sneak preview of what we're going to be seeing here. So the planet will appear as a little disk, and tonight looks like we've got 3 of the largest moons of Jupiter will be visible. Looks like Io is behind the planet, so we will not see that. So these moons are really quite large, and you can see them even in a small telescope. You can spot these satellites, and even pair of binoculars. These are so big that you can see them in binoculars as well. So it's kind of fun to look at. And if you watch them over just a couple of hours, you'd actually see them move in the orbits around the planet. So that's kind of fun too. Those moons are known as Galilean moons, after the famous Italian astronomer, who first turned the telescope towards Jupiter and saw them there. He thought they looked like little stars orbiting around Saturn, around Jupiter, but we now know that they're moons. And so Mark is repointing his telescope towards Jupiter.
I could share what I have if you want to have a
Oh, yeah.
look.
Yeah, sure. Go ahead, Tom.
I don't have it perfect yet, but it's 90% there. Okay, so here's Jupiter,
Yeah.
and you can kind of see the belts. I'm trying to eke out with the camera where we can boost the contrast tiny bit. Okay. Might not be able to get much better. That would be too dim. This might be the best I can get it tonight because of the atmosphere. Yeah. Unfortunately, you can barely see. These are the two equatorial belts.
Yeah, yeah. You just about barely see them there. Yeah, yeah.
South is up because this is a Newtonian. It's upside down.
Right, it's upside down view of the planet.
Let me see if I can eke a little bit more out. Every object is a little different. Yeah. No, barely.
Yeah.
Barely. So if we want, yeah, you can barely see the belts.
Yeah, yeah.
Yeah, we were doing a little better at Saturn. So what I'm going to try to do is back this out. And from here, I'm going to change our resolution or gain to see if we can overexpose Jupiter, but we'll then be able to see the moons.
Yeah, there you go. Yeah.
Yeah. Let's go to yeah.
Yeah, so there you get the three moons
of them here,
yeah, all three lined up in a row. Io must be behind the planet somewhere, so we can't see it. But there you go.
The half a second.
Three of the four largest moons there. Remember correctly, Jupiter is up to, what, 79 moons, I think.
Yeah.
Yeah. Quite a bit. All right, there we go. Yeah, so these will definitely change. If we came back in an hour or so, I'll lose it because it'll go behind a tree. But some of these moons, you'll see if they've changed position.
Yeah.
And even in that little bit of time,
yeah,
you can notice that.
Yeah, another fun thing to look for sometimes when you're looking at Jupiter, you'll notice a little black spot on Jupiter. Not very prominent, they're very tiny, but those are the shadows of the moons can occasionally be seen as they cross the face of Jupiter. And that's kind of fun to look for those, especially if you have multiple shadows crossing at the same time. So those nice shadow transits going across the face of Jupiter, kind of neat.
I'm about to lose Jupiter behind the tree.
Yeah.
You want me to hit the next object, or does
Sure.
Omar have something? Or
I don't know. Omar,
Yeah, I've got M31.
Oh, great. Okay, let me share my screen again.
Yeah, I'll back this
show
off.
them where M31 is. We're pointed kind of in the opposite part of the sky here. So let's pull back. And so in order to see this next object, which is called M31, otherwise known as the Andromeda Galaxy, you got to look over to the eastern part of the sky. And what you want to look for is, well, for the first thing you want to look for is actually one of the neighboring constellations. You want to look for Pegasus. Pegasus is a nice constellation, not very bright, but a big constellation that is rising up higher in the eastern sky now that we're in the fall. And as you look towards the east, you want to look for a square or diamond shape. So these four stars, not very bright, but they're this nice big square or triangle shape. And that makes up a part of the constellation of Pegasus. And so there's the body of Pegasus, his head and his nose. You got the star out here that makes up the nose of the horse. You got his legs kind of sticking up in the air there. Odd thing about Pegasus is that he does not really have back legs, but a lot of people like to steal these stars. There's actually two rows of stars here, kind of this big V shape, and we use those as back legs. But really what that is the constellation Andromeda. So you've got Pegasus, there he is, there's his head and his neck, the square represents his body, and his back legs are really the body of the princess Andromeda. And so this is the constellation that we're looking for. The object that we're looking at is in the constellation of Andromeda. And so if we move over here, just remember we're still here in the eastern, or a little bit towards the northeast part of the sky. We got this kind of V shape of stars. And right here you see that there's a little fuzzy spot in the sky. And this is where you'll find the Andromeda galaxy. And it is big enough and bright enough, close enough to us, that it actually is visible to the naked eye if you're under dark skies. If you're away from city lights, you get a nice view of this with the naked eye, and it looks nice in binoculars. But under light blue skies, it's a little tough. You need binoculars or a small telescope to pick it up. It is 2.5 million light years away from us. It's not the closest galaxy, but it's the closest large galaxy to us. And it's pretty amazing. It's a little bit larger than our Milky Way. It probably has something like almost a trillion stars in it. And it's a very popular object with amateur astronomers. And Omar, if you could share your view, we'll take a look at it in Omar's telescope.
And I'm going to apologize ahead of time because of my internet connection, but hopefully you guys are seeing this now.
Well, it's coming up. There we go. Your audio is kind of dropping out a little bit, but we can see fairly well. And oh yeah, that's a nice view. That's a nice view. If you could point to the core for us, the telescope is pointed at the core of the Andromeda galaxy M31. It's the 31st object in the Messier catalog. That's why we call it M31. And you can see the core of the galaxy. And you can see a hint of, just kind of this oval haze around the center of the core. And I can see at least two dark dust lanes there on the upper left part of the galaxy. And so you've got some gases there and gas and dust that are blocking some of the starlight. And so you see these dust lanes there. So that's actually really quite a nice view, especially considering that we do have a little bit of moonlight in the sky tonight. And so there's M31, 2.5 million light years away from us. And as I said, something like almost a trillion stars in it. It's, as I said, bigger than our Milky Way, about 220,000 light years across. So it's almost double the size of the Milky Way. So a pretty big galaxy that is close by to us. And another interesting thing that you can see here are one of the satellites of one of the satellite galaxies of M31. If you look on the upper left here, you see another smudge over here. And if I remember correctly, this should be M32, no? Omar?
Up at the upper left you're talking about?
Yeah, upper
I
left.
think that's 110.
Oh, I'm
I
sorry.
think yeah.
You're
And
right,
then 32 is the closer one down in the
Right.
like the 530 position.
Right, down the bottom. Yeah, I got that flipped around. I forgot we're looking at it upside down. So yeah, that's M110, and then the satellite galaxy M32 down the bottom there is orbiting around it. And our own Milky Way has some satellite stuff as well. There's two irregular galaxies we call the melogenetic clouds that are only visible in the southern hemisphere that are orbiting around our Milky Way. So these are satellites of these galaxies. And so two pretty good sized galaxies fairly close together. And As you've perhaps heard, these two galaxies are on a collision course. Their gravity is attracting each other, and so at some point, billions of years from now, these two galaxies will probably collide, though not in a normal sense because they're not solid objects. They'll pretty much pass right through each other. You know, galaxies are mostly empty space. I mean, sure, yeah, there's lots of stars and gas and dust, but a lot of it is empty space, and those two galaxies will really pass right through each other. So kind of an exciting event, but it won't happen for billions of years. And if we might be able to also check out the third galaxy that is nearby to us. The galaxies that are close to the Milky Way, we have a name for it, not a very original name, they're just simply called the local group of galaxies. And Andromeda is the biggest, the Milky Way is the second biggest, but also there is a third biggest galaxy called M33 in our neighborhood. And perhaps we can pick that up tonight as well as we're looking around the sky here.
That's a hard one. It's very diffuse.
Yeah, that one we may not get a very good view of, but we could try it if we have time.
Right. Yeah. You know, up here by my sky, it would work. Once it clears the tree, I might be able to get it, but it still hasn't reached there yet.
Oh, okay. Okay.
Yeah. But yeah, that's a beautiful shot, Omar. Nice job.
Yeah, that is a very nice view.
Yeah.
Especially considering the moonlight, you know.
Oh yeah.
So Mark, what do you think we should go for next? You think M13?
I just centered the Dumbbell Nebula.
Oh, the Dumbbell, sure. Okay, yeah, great.
Yep.
Let's check out where the Dumbbell is. I'm gonna swing our view back around. Now, of course, the star pattern that we know as the summer triangle is still visible, of course, even though summer is over. It's still here. It's shifting off to the western sky, and part of it is still directly overhead. So if you face south and look straight up at around 9 p.m., you'll notice the three bright stars of the summer triangle sitting overhead there. And so Mark's telescope is pointed towards the middle of this pattern. Whoops, I seem to have zoomed in a little too close here. Hold on a sec. There we go. What we're about to look for is M27. The Dumbbell Nebula is right there. And so right inside that triangle of stars, you've got a constellation here called Vulpecula. And this is kind of a very faint constellation. There's just got a couple of stars in it. It's kind of not very impressive. When I'm looking for M27, I actually go and I look for the constellation below it, and that's Sagitta, which is a much nicer pattern of stars. It's much brighter and easier to pick out. So I look for the triangle, the summer triangle, look for that little arrow shape inside of the triangle. I look for the tip of the arrow, and you go up and to the right a little bit, and that's where the Dumbbell Nebula is. It's just over the border in the constellation Vulpecula. But if you zoom in, you get this nice little fuzzy spot there in the evening sky there. And so right near the tip of Sagitta, the arrow. And so that's what the object, where the object is located. We're going to take a close-up look at it through Mark's telescope, and we can describe a little bit about what this object really is.
There you go. It came out pretty nice tonight.
Good.
So here we are.
Yeah.
Yeah,
nice view. Sure.
Yeah, it came out with a nice view.
Yeah.
And the harder to see details are coming out too. Some of the dust lanes and the bow shock are really popping out this evening.
Right. We featured the Dumbbell Nebula during our summer stargazing event with the North Museum back in July. And this is what we call a planetary nebula, and which is kind of a misnomer. It really has nothing to do with planets. Originally, when these objects were first found, astronomers were using very small telescopes, and they look like little blue-green disks in the sky, and they kind of look like Uranus and Neptune. And so that's how they knew they weren't planets, but they kind of look like that, and so they became known as planetary nebula. What they really are dead stars. This is what eventually will happen to our own sun. Billions of years from now, when the sun runs out of fuel, it will become a red giant star. It gets bloated, and it throws off some of its outer layers as the star dies, and that's what is left behind. You get these big clouds of gas that are left behind by that type of event. And so that's what this is. It's the remains of a dead star. And so down inside that nebula is a white dwarf star, what we call a white dwarf star. It's kind of a carbon ash left over at the center of the star, and that's the only thing that's left, a very, very hot ember of a star at the center. And the nebula is kind of lit up by that white dwarf star. The gases that it's thrown off is illuminated by that white dwarf star. And so that's
radiation,
what we see,
yeah.
the radiation, right? And
Right.
this happened, and a lot of people, when we look at things like this, want to know, well, how long ago did that happen? And we estimate, just from the expansion of the gases, we estimate that it's about 15,000 years old. So 15,000 years ago, thinks what life was like here on Earth, and that's when this star was dying.
Had glaciers here at that time.
Yeah, that's right. That's right. We were still in ice age at the time,
Yeah.
So that's pretty amazing to think about.
Yeah.
By the way, this is about 1,200 light years away from us, so not in our immediate neighborhood, but not too far away. And right now, the gases have expanded outwards, and it's about 3 light years in diameter. So you're still looking at something that is quite a bit bigger than our solar system at this point.
So, Kevin, I have the fact that you mentioned it's 3 light years in diameter. If it's roughly 4 light years to Alpha Centauri, would that shell, if our star hypothetically was at the center, would that outer part of the bow shock of the shell be 2/3 of the way, or 3/4 of the way rather, to Alpha Centauri?
Yeah, would only be for reaching out to the next star. Yeah. That's one way of thinking about it. Yeah.
Right. Interesting. So if a star in our local neighborhood many thousands of years ago, decided to give up the ghost, we might be sitting in a shell of gas and dust.
Yeah.
That's interesting to think about.
Yeah.
Interesting to think about that. But hey, Omar, did you happen to get the next object?
Hold on for a second. Yeah, because I'm on this laptop, so I didn't get I don't have my emails here. What's the next one you guys want me to go to here?
If you were going to do if you could try to get M33, I'm not sure if you can get that.
Yeah, too low for me. It's just
okay. Still too low. Okay. That's fine.
How about the Perseus double cluster? That's another one that that you should be able to get. If while you do that, I could probably go off and do another object as well, or unless you wanted to do the veil, or I do the veil. Either way.
Yeah, I'll try for the veil. Let me see if I can
the
get
veil.
that.
Okay.
Yeah, let's do the veil because that's not far from here where we're pointed now.
That's in the same general vicinity. Yeah.
Yeah.
It's in the area.
It may take me a minute here because hold on.
Yeah.
So this would be a sun-sized star exploding. The veil.
Yeah.
Do we know the size of the star that used to be in that white supernova?
Good question. I'm not really sure offhand how big that star would have been, but
right. These are 2 very different events.
Right. Yeah. This is sort of a sun-like star, and this, by the way, is bright enough that if you have some decent skies, you can see it in binoculars. You can see a little kind of blue-green kind of little puff in binoculars or in a finder scope for a telescope. And, but once you zoom in, you see this nice structure, and you can see why we call it the dumbbell. It really does have kind of a dumbbell shape to it.
That or an apple core. Like you have
Yeah,
to
or an apple core. Yep, there you go. The apple core nebula. Yeah, yeah. So let's see if he's going to go off to the Veil.
Try that in Stellarium. Yeah, that might be.
Yeah, let me show you where we're going to be pointing.
Stop screen sharing here.
NGC.
Okay, all yours.
Okay, so we're going to be pointing Omar's telescope not too far away from where the Dumbbell Nebula is. We're going to be looking in the constellation of Cygnus. And so Cygnus is right over here. It's part of the triangle. The star that marks the tail of Cygnus is part of the triangle, so that's Deneb. And you can see why Cygnus is sometimes known as the Northern Cross. You've got this upright piece right here, and then there's a cross piece like that. But usually people like to imagine this as a swan in the sky. So there's the long neck of Cygnus and the big wings spread out on either side. So there's Cygnus, and we're going to be looking at a fairly well-known nebula, which is called the Veil. And so that's right near the wing of Cygnus. And so we're going to zoom in here. And so here's where you'll find the Veil Nebula. And I'm not sure which portion of the Veil Omar is going to be pointing at here. We could ask him once he's set up. But it has basically has two pieces to it. It's got the eastern side and the western side. And often you'll see it. This is really quite such a large object that often you'll see them imaged separately. But if you put them together, they kind of form this kind of loop shape. And this is a similar event to what we just saw with the Dumbbell Nebula, but this was a much larger star. You're talking something like probably 8 to 10 times more massive than our own sun. And as it reaches the end of its life, it becomes a red giant star and bloats up just in a similar way, throws off some of its gases. But over time, it continues to burn more and more material until it gets to the point where it starts to try to fuse iron. And when it does so, well, fusing iron doesn't create energy, it uses up energy, and the star collapses. And the star collapses, and once that happens, you get this tremendous explosion, and that's what we call a supernova. So this is a supernova remnant, and that's what we like to call it, a supernova remnant. It's the stuff left over from the explosion of a giant star, and these gases have been thrown out into space really quite far. The gases there at this point are about 65 light years long. So they're spread out over quite a large area. And so we kind of figure that this event, the supernova, happened maybe 10 to 20,000 years ago that this event happened. And so we're seeing the leftovers of that. And the diameter of this whole veil area is about 3 degrees, which is pretty good. That's much bigger than the full moon. But it's so faint that it's a little bit difficult to see unless you've got a telescope. So that's what Omar is pointing his telescope towards. Omar, are you pointed?
No, it's not. Yeah, it's not quite there yet. Mark,
Okay.
You may want to try to grab it.
Oh, okay.
We'll have a little race here. Which of you can get it first, Omar or Mark?
I'm actually on M15, but I can move back to the Veil if you want. All right, let me get to the Veil just a second.
Okay.
going to start stacking images.
Okay.
Okay. So we'll share my screen, and I'll do the fine tuning as we're here.
Oh, yeah. Well, that's pretty good already.
Yeah, it's actually not bad. It's only stack 3 of them. So what I mean by stacking, so if you look over here, I'm taking 10-second exposures. I could probably go as long as 20 if I wanted to. I'm using a altitude azimuth mount. So basically the telescope goes up, down, right, left. But if I expose any longer, I will start getting out of round stars and the like. But what they're doing is, instead of taking a long exposure and keeping the camera open for 2, 3, 4 minutes, it's stacking these 10-second exposures one on top of the other, and so increasing the exposure time.
Yep.
And you can see little by little that the image is actually getting better.
Yep. Yeah.
As we speak here. So you can actually zoom in and see and there's different colors here, and then the different spectra.
Yeah, you really can see the tendrils there of gas
Right. Absolutely.
that got blown off of this supernova. It's pretty
Supernova,
cool.
right? And this is just one tiny part
Yeah.
Of that supernova, and that was that happened some, I think, 6,000 years. Correct me if I'm wrong.
It's at least the latest estimate that I saw is somewhere around 10 to 20,000 years old.
20. Wow.
Yeah.
So that's at the height of the ice age. So it'll be somewhere in there.
Yeah. So this star was, roughly speaking, about 2,400 light years away from us at that point. When it blew up.
So Omar just messaged me saying he's lost his Wi-Fi connection. So
oh dear,
we're wait for him to come back.
Okay.
But
Yeah.
we're still looking at the object here, which is fine. If you want, I can also. So basically, if you remember the Dumbbell Nebula, and we talked about the bow shock, and basically that's the where the gas meets interstellar space. And so what we're kind of looking at here is a much larger front of that gas going against the interstellar space, and it's had a lot more time to expand than the Dumbbell Nebula has, and it's probably going at a higher velocity also. But this takes up a much larger portion of the sky than the Dumbbell does.
Right. Oh yeah.
I don't know if Stellarium can show you what that looks like, the expanse of the whole supernova remnant.
Yeah, I was just showing that on.
Oh, you were? Okay. I'm sorry.
It does show you the whole kind of loop shape of it, if you're able to see the whole thing at once.
So there's an interesting phenomenon here. You see how just happened at the top part of my screen cut off there, and this
looks a little askew there.
Right, because I have an altitude azimuth telescope. It's still stacking the images, aligning them up, but that's the actual rotation of the sky now. That's how much the picture is rotated out.
You get a little rotation there,
yeah.
The telescope moves as it's tracking the sky.
An equatorial mount wouldn't show that, but that's an aberration. So if anyone wonders why that's happening, that's the reason. As we stack these photos, they're kind of right up by this object is right up at the zenith of the sky right now. So it's not just moving from east to west. It's actually pivoting also a little bit. So you have some of this rotation going on, which is pretty interesting. But so that's that is the eastern veil. If you want, I can try the western veil.
Yeah, sure. We're in the area as well. swing
So
over
let
a
me
little bit and check the western
let me
half.
go to, I think it's 6990, if I remember correctly, is the western one. 699. Oh, okay, it shows the telescope moving here.
Yep.
And you can see this is the other side. It'll settle out. Okay, I'm going to set the exposure low. Just a second here. I forget the name of that bright star.
I think is it 52 Cygni?
Yes.
Yeah,
Right.
I think it's 52.
52 Cygni, right? Let me see. Okay. I'm just going to get that kind of centered. Let's stop it right there. And exposure 5, put that to auto. Let's see. Okay. Let's get 10 seconds. Hopefully that won't blow that out too much. Let's see what happens here. We go through one whole exposure. 10 seconds. All right, let's go. Any more, we might blow out the star.
Yeah, you got a
So,
kind of difficult image because you've got a bright star in the field and you're trying to pick up
right.
something that's very faint. That star 52 Cygni, by the way, is not really related to the Veil Nebula, as far as I know. It's either in the foreground or the background. I'm not quite sure which. I don't remember what the distance is to that star.
Right.
But I'd imagine it's a foreground star. It just happens to be in the way, so to speak.
Right. Yeah, it would make sense that's foreground. Brightness. All right, so as it stacks, I'll wait till the 5th stack. 5, okay. Move this over. It's too much. Try to bring out some more detail. That might be the best we do right now, even with the moon here.
Yeah. Well, it's not
This will.
you can see
So this is the other side. The reason why they call it the east and the west. We can notice the curvature is going the opposite direction
right
from the central point, and so this is also been called. I think this is also got a nickname called the witch's broom too.
Oh, right. Yeah, I forgot about that. Yeah.
So yeah, as this exposes, more will come out. You're right, though. This star is kind of swamping the camera lens, so to speak. Yeah. If I lowered the gain, that would make this get too dim. I'm sure there's some things I can do to mess with this, but you guys get the point, I think.
Yeah, that's good. Okay, so there's the two halves of the Veil Nebula. Let's see. Looks like we lost Omar there. Fortunately, his Wi-Fi connection must have gone down completely. So we'll soldier on without him. Let's see. What do you want to do?
Maybe a globular cluster like M15 or something.
Yeah, that's what I was thinking. Either M15 or M13, whichever.
Yeah, I just lost 13 behind a tree, so I think.
Okay. Well, M15 is almost as good, So let's swing over towards that. Let me.
I actually have Mars.
Oh, you got Mars.
Yeah.
Okay.
I can try that.
Yeah, let's give it a try. Why not?
Yeah, before that goes behind the tree. Yeah, I kind of have to go with what the topography. Then we'll go back to 15. 15's got a nice big open swath of sky, so we'll try that.
Right.
So planet. Okay, so we'll say goodbye to the veil.
Right.
I'll stop the stack.
Okay.
And we can watch the telescope slew away.
Let me share my screen and show
Yes, go
folks
right
where
ahead.
we're pointing. We looked at Jupiter and Saturn over in the southern and southwestern sky. And if we turn and look over towards the east, underneath where Pegasus is down low in the eastern sky, we can see that Mars is reappearing in our evening sky at this point. And so we're headed towards opposition. Mars is headed for its opposition on, I think it's October 13th, if I remember correctly, next month. And so on October 13th, it'll be at its closest point to us. It'll be opposite of the sun in the sky, and so it'll be in the sky pretty much all night long. And so this is going to be a pretty good appearance of Mars. 2 years ago, we had opposition of Mars that was very, very close. But unfortunately, when those close approaches happen, Mars is very low in the sky and it's kind of difficult to view. Plus, on top of that, we had a really bad dust storm that was happening. And so we really didn't get to see too much detail 2 years ago when we would normally have a nice view of the planet. It was kind of blank, you know. It was kind of this big orange ball that you can look at in a telescope, but it wasn't terribly interesting. So this appearance of Mars, even though it's not quite as close as it was 2 years ago, actually is going to be pretty nice, I think. As it rises up and gets higher in the sky, we'll get a nice view of it. Hopefully there won't be any really bad dust storms the way there was 2 years ago, and we'll get a nice view of it, hopefully, as time goes on, as it gets closer to us and gets higher in the sky. So let's see. I'm not sure. We're in the constellation of Pisces. Yeah, that's right. That's in the constellation Pisces. Pisces is a tough constellation to spot. It's a very faint stars. So you kind of look for this big V shape of stars underneath Pegasus. The easiest part of Pisces is the head. You got this little bunch of stars here, which is known as the circlet of Pisces, and that's located very close to the body and the head of Pegasus. Mars is down the bottom of the constellation, right inside that V, and so that's what Mark is going to be pointing at. Is pointing at Mars here down low in the east. And so let's see what that looks like.
Yeah, I don't know if I'm gonna get. It's always hard to get surface detail on Mars under the perfect conditions.
Yeah, it is very low at this point. It'll get better as time goes on, but
wait a minute.
that's actually not too bad.
That's actually not too bad.
Carefully, I can see some little kind of dusky, dark markings on the surface there, which is actually not bad considering, you know.
You're right. That might be the best we're gonna get, but there is definitely something there.
Yeah, I definitely see a little bit of detail there. So there's some areas where there's a little bit of darker rock there, and so that's why it appears as if this dark
Being
marking.
downward, so
Right.
well, maybe it's a Sirius Major. That's purely speculation right now.
Yeah, it could be Sirius Major. That's one of the prominent features on Mars.
Yeah.
But I'd have to look it up to see what side of Mars is facing us.
That's right.
The planet turns a little bit slower than Earth does. Its day is about 20 minutes, or is it no, I think it's about 40 minutes longer than Earth's. And so different parts of Mars are visible as the nights go by. And so Sirius Major is not always visible, but I'd have to look it up on a map to see whether or not it's facing us tonight, to see if we can identify that particular feature that we're seeing there. But remember that long ago, an astronomer named Schiaparelli was looking at Mars and he saw these dark markings and he described them as canali. And I forget what that means in Italian, but it was mistranslated into English as canals, and people thought that there was a civilization, that was a sign of civilization on Mars, and that's where our whole idea of little green men from Mars comes from. But we now know that those are not canals; they're just dark markings on the surface there. And we do have a spacecraft on the way to Mars right now. We've got the Perseverance rover, which is almost a duplicate of the Curiosity rover, but that's on there now. Has some different instruments and a slightly different mission, but it'll be landing in February. It was launched back at the end of July, and it'll be landing sometime in February, I think February 18th. Is the date that sticks to my mind of 2021 that it will be landing and starting a mission. So that's kind of like exciting to think about as you look towards Mars in the nighttime sky. We've got a brand new spacecraft headed out there towards the planet. Now, of course, as some of you may know, Mars does have two moons, Phobos and Deimos, which translates to fear and panic, and which sounds horrible, but remember that Mars is the god of war, and what accompanies war? Fear and panic, and so that's how those moons got their name. You won't see them here in this telescope, or really any backyard telescope. They are little tiny chunks of rock. They're so small that you really need a huge telescope. You need a professional telescope, sized telescope, in order to see those really through an eyepiece. They're really tough to spot. So they don't show up. They're too dim to show up in an image like this. Okay. So actually, a pretty decent view of Mars there tonight. So that's good. We got Jupiter, Saturn, and Mars in view, which
You
is
got
nice.
lucky. It's just about to go behind a tree.
Okay. Good. Glad
Snuck
we
it in.
snuck it in there. Yeah.
Yeah,
Good.
yeah. That's good.
Do you want to
All right.
move on to M15?
Yeah, let's try that.
And I think we'll wrap it up there.
That's a perfect place to wrap it up, actually. Yeah.
Let me switch my view back to the sky.
We stop the share.
And we are using, I think Mark mentioned it earlier, we're using a program called Stellarium. This is a free program you can download from stellarium.org. You can download it to a computer. You can also download it as an app on a phone. And it comes in really handy for finding things around the sky. And the star cluster that Mark is going to point to next is located in the constellation Pegasus. And the easy way to find it is to look for that square or diamond shape in Pegasus, and then follow out along the head and the neck and go to the nose. And this star here is called Enif. So that's the star Enif. And if you follow out, you get these two stars here. If you follow this line through Enif out into this area, this is where M15 is located. So this is the 15th object in the Messier catalog, named after Charles Messier. And if we zoom in, right off the tip of the nose of Pegasus, you'll see this little bunch of stars right in this area. And so this is M15. This is a very nice cluster for the fall, nice viewing for the fall season. It's fairly bright and not too hard to find. You can usually see it in binoculars if you've got some decent skies. So let's see if Mark has got
the center it, yeah.
Okay, yeah.
Yeah, I'll share screen as I get it in there.
Yeah.
Okay, so there we are. Let me just get this down. It'll look better in a minute. Moving the telescope. Huh? Too much. One more should do it. Okay. go to, and we'll zoom in. And gain will go. We're back on, noise reduction back on. And put it on low and increase exposure to 5 seconds. So I'm changing the exposure time here.
Yeah.
There we go. So the interesting thing about M15 is supposedly there is a supermassive black hole at the center of it.
Right. Yeah. So this cluster is a globular cluster like M13, which, if you saw our summer stargazing event, we did have M13 in view, and this is and that's a big star cluster. This is somewhat smaller. I don't recall offhand exactly how many stars, but you're probably talking 400,000 to 500,000 stars in this cluster. So it's a bit smaller than M13, but still a very nice cluster. You're talking somewhere in the range of 20 or 30,000 light years away from us, I believe. And so it's pretty far out there.
Right.
Orbiting our galaxy, all these globular clusters are also kind of satellites of the Milky Way, and they're orbiting around. And so you're having a pretty nice view of M15.
This is a tight globular as well. If you actually start to increase the magnification, you can see how many stars are. My focus isn't perfect. That's okay.
Yeah.
But you get the idea of how many stars. You can see how close they are to each other. So one can imagine if you're on a planet orbiting one of these stars, that's your nighttime sky. You wouldn't have a nighttime sky. Just to be...
yeah, pretty much. Your sky would be just lousy with stars.
Right.
You know?
Right. So maybe it's kind of good that we're not inside one of these looking out. We'd never have a night.
Yeah. Some civilization living near the center of a globular cluster would be pretty ignorant of the universe around them because there'd be so much starlight. They
Right.
wouldn't be able to see other galaxies, maybe even. I'm not quite sure how what they would see from the center, but it'd be kind of tough, I think.
Focusing, so just tweaking it.
Yeah,
just a little bit more, but you get the point.
Yeah.
It should settle out the next one. Yeah, it's good. But so this guy's in Pegasus.
Yeah.
So
right off the nose of the horse, and so pretty easy to find. Usually scan with binoculars.
Right.
Out away from the nose, and you can usually pick it up as a little fuzzy spot there.
Right. So as you back out, you can see how small it is relatively. M13 in the same frame is about maybe this much around.
Right.
So you have to really zoom in. Yeah. With 15, it's tiny. But I think we're about done. It's too bad.
Well, I see Omar has come back online. I'm not quite sure how good his connection is, but if Omar can hear us,
the Pelican Nebula.
You guys hear me okay?
Yeah, we can hear you. Yeah.
Sorry about that. I'm on my phone now using the internet there. But, I've got. It's not the greatest thing, but it's IC 5068, which is an emission nebula.
Oh, okay. Well, let's take a look at that, and we'll.
Got my share here.
Yeah, we'll finish up the evening with an emission nebula.
Yeah, cool.
So let me see. Just a smaller section of it. Let me see. You should be seeing it right about now.
Yeah, nice.
Ooh, look at that.
Yeah.
And if I think this is like right beneath the Pelican is where you find. So that's down east of the Cygnus Wall.
Right. So this is in the constellation of Cygnus.
Yes, yes.
Yeah. And what's the name of it again? I don't think I'm familiar with this particular nebula.
Yeah, it's one that's kind of overlooked.
Yeah.
It's I think it lies about 1,600 light years away or somewhere around there.
Okay. Okay.
And,
Well, what's the name of it again? I see.
yep. And it's basically glowing red due to emissions from atoms and hydrogen gas. So
Right. Right.
So where in the sky is it? It's in Cygnus?
Yeah.
You said, or?
yeah, excuse me. Yeah, it's east of the Cygnus Wall and like sort of right beneath the North American and Pelican. And it's IC 5068.
Okay. 5068. Okay. Yeah.
Yeah, I mean, some people say that it looks like a bent out of shape square with extensions diagonally at the top, left, and bottom right. So
Wow. I can't really see that, but
yeah,
oh, well.
neither do I. But this is this is what they some people say anyway. But
Okay.
yeah, I mean, to be honest with
Very
you,
nice.
this is the first time I'm looking at this one. I actually had to look it up on the net to see exactly what it was supposed to look like.
Right. Right.
Uh,
Yeah. Kind of neat to
That's
look at. Kind of neat to look at
nice.
something new. Yeah. Okay. Well, I think we are. I've given people a pretty good view of some of the objects that are visible here in the fall sky. So I think we're going to end our broadcast there. I'll end on a high note with a new object there. And so thanks for joining us. And if you would like some more information about events at the club, visit our website at njastro.org. We're also on Facebook as the North Jersey Astronomical Group, as well as on YouTube. And you can check out some of our previous events and presentations there on YouTube as well. If you're listening to this in October, we do have an upcoming event towards the end of the month. We're doing another fall stargazing event with the Passaic County Parks Department, and so and that one's going to be focused more on kids. And so if you have kids yourself or grandchildren or nieces or nephews, you can register for that. You can go to Facebook or our website, and you can check out the details on that. You do have to register for it, but it is a free registration, and so check that out. So thanks for joining us, and enjoy the nighttime sky.